In this lesson, we're going to look at getting digital. If you recall from last week, we talked about abstraction, looked at an instruction, which is an abstraction for a command name. We looked at functional abstractions, which were abstractions for groups of operations. In this lesson, we're looking at abstracting digital information. How has computers and digital information become game changers? How have they created opportunities? Kind of going back to chapter 1 again, looking a little bit at history as it refers to digitization, a little bit. I'm going to leave you to explore a little bit more in our discussion on that. We will also look a little bit forward into what we're covering this week and next week on binary numbers. Problem with writing. Our forefathers decided every 10 years that the United States was going to have a census, and people had to go door to door and record, but only people could read that. In 1890, digitization occurred for the census. Here is a hollerith card, which is a punch card, and this contains census information. One interesting tidbit is that the United States Census was one of the first purchasers of a computer for the 1950 census. This is an example of the machine that counted those punch cards. It was mechanical, some electronics to it, but it counted mechanically. There was, to read the card, there was a metal brush. So here's an image of how it happened. So here's the punch card, and the brush is rolling along here. And as long as there's not a punch, nothing happens. As soon as there's a punch, you notice there's contact made between the current, and an electric impulse goes out for the counting. The machine read cards. Women went in one slot, men went in another slot, and there were two piles, and it was ran again to count them. So here's the old way. Kermit's doing the old way, had to go sheet by sheet, counting for the census. But digitizing makes information discrete. There's either a 1 there or a not a 1. That's what discrete means. Discrete means there's no in between. There's no 1.5. It either is a 1 or it's a 0. A machine can determine that easily, either mechanically, as you saw in the previous example, or electronically, as it is done now. Once data is digital, it's just a matter of engineers coming up with capable machines to read it. In addition to having to read punch cards were also written, and that stored the data. So we're having input and output digitized. I like to say that my mom was a key punch operator. She took key punch operating class right here at Blackhawk College many decades ago. So here is a device similar maybe to what my mom did. And here's a card coming through, and this die would punch through in the appropriate place. So by the mid-20th century, around 1960, large and medium-sized companies used card-based digital data for mechanical processing. IBM was really big on this. And then computers began to replace the mechanical because the computers could process instructions. They could program. So you could either build one mechanical device that served one purpose, or have a computer that could be doing counting for many things and reading punch cards for many things just by changing the program. More flexible. There is a mention here of the Y2K problem. The Y2K problem was around as we turn the millennium. And it all stemmed back from way back in 1960. If they thought it was a good idea, because memory and storage was at a premium, to store years in 2 digits instead of 4. So instead of 1961, 61 was stored. Well, when this idea came up, would you think by 1999 they would still be using the same data? And guess what? They were. I was working for a company that had subscriptions, and we were using 2-digit year formats. People whose subscriptions should have ran out in 2001, our computer was calculating that their subscription was already expired in 1901. So all that code had to be reprogrammed so that 4-digit years were being used. It was very expensive at the time. If you recall, the second generation was transistors, and a transistor is a switch. And here's a gate. A gate is open or closed, so kind of like like a hole in a punch card. If the gate is closed, then there's no charge that can come through. If the gate is open, that charge can come through. Chapter 4 of our Computer Science Illustrated book does talk about circuitry. It talks about the circuitry in transistors, AND gates, and OR gates. We are not going to cover it, but if you're interested in learning more about it, it is there in Chapter 4. By the time the IC chip came around in the third generation, photolithography was being used. So we were photo stamping onto silicon the transistors, the switches. Transistor switch wires on and off in solid material. So in IC chips, there were no moving parts to wear out. The ICs are fabbed as a unit. There's no wiring. And using photolithography, complexity of circuitry doesn't matter because no one's actually wiring it. The next big thing in the fourth generation, personal computers. However, if it was up to Ken Olsen, we would not have them. In 1977, he said there is no reason for any individual to have a computer in their home. In fact, there are a lot of fun quotes like this in computer history. So as you know, in the fourth generation, which is what we're in now, computing comes to everyone. Regular folks, you don't have to be in the government or a scientist, can now have a computer for their interests. This created a big demand for digital data, and as you know, news, pictures, audio, video, books, everything is being digitized. From 1985, most new information is digital, and we are all storing lots of information that we would not be able to do in the past. Also in this generation, as you know, the internet came about. Now the internet was invented in 1969. It took over 20 years, though, for it to come to us. Computers are useful. Connected computers, such as connected on the internet, are awesome. If you have N computers that are connected, we add one more computer, you have N new connections. And we're communicating with friends and businesses all over the world in different time zones. In fact, 2 days ago, my grandson was born in Tampa, Florida, and I have already seen tons of pictures of him. He's very cute. The internet is a general mechanism to communicate digital data. It doesn't matter what it is. Music, email, video, we're connected to the world. And we're all talking the same language, the language of hypertext transfer protocol. All computers are talking this language, and publishing is not centralized, it's decentralized. So there's no limit on how you can publish. Anyone can set up a web server, if you know how, and add it to the internet. The World Wide Web exploits one protocol, neutralizing differences at endpoints. The internet's universal medium lets us look at other people's digital info. So the key principle here is digital. Digital encoding. Physically, information is the presence or the absence of a phenomenon at any given place and time. So we started talking about punch cards. The phenomenon was a hole in the card. So is it present? Then it was detected by that brush making the electric contact. Is it absent? Then the brush was insulated from the electrical source by the card. The place, there are several places on the card. Devices know the positions to look for the holes. And time, a hole is permanent representation of info. So the general idea, moving beyond the punch card, is that detecting the presence and absence of a phenomenon is digitization. So whether the phenomena is light or magnetism, charge, mass, color, current, detecting depends on the phenomenon, or can I call it media? Okay, is it a flash drive? Is it your DVD? So how are those presence or absences happening? The result must be discrete. It's either there or it's not. There's no sort of there. No hanging chads here. The place and time apply, but usually default to the obvious values. This is going to lead to our discussion for this topic. In this discussion, I want you to look at those other phenomena besides punch cards. So how else is that hole happening in that DVD, on that flash drive, on that hard drive? Be interested in seeing what you say.